There's a couple of companies who have actually dealt with things like performance management in these new worlds, and how do we identify issues and bottlenecks in software and whatnot. And I think one of the leading companies in this space is Lightstep. And we're honored to have the CTO and co-founder of Lightstep join us today. So Spoons, if you want to come to the stage, it'd be great.
Thomas Millar from Stitchfix. I'm going to be joined today by Thomas Millar from Stitchfix. We're going to talk a bit about deep systems, about the kinds of architectures that folks are building today, some of the ones that Thomas has helped build, and how the way that we're building those things is changing the way that we observe them and the way that we operate them. Before we have that chat, I want to set a little bit of context. It's a bit of a worn refrain. Of course, software is becoming a more important part of our lives, the way that we buy books or clothes, homes, cars, the way that we exercise, what we eat, how we get around. And the thing that's cool, I'm excited about that in a lot of ways. The thing that's a little bit scary to me is that the complexity of that software is also really increasing in a lot of ways. So just to kind of juxtapose two kinds of complexity here. And whether that's through something like microservices, whether it's polyglot applications, more frameworks, it could be things like multi-cloud or hybrid cloud. There's cloud providers, third-party vendors, all kinds of pieces of the puzzle that are coming together. And as we put all those pieces together, the stack is getting deeper and deeper. So I want to talk a bit about that and what I mean by deep systems, and I want to do that by way of example to start. So the first kind of scaling, so we talk about scaling, we scale up our systems, cloud providers are making scaling more easy. This is one body of water, a puddle, and if we keep adding water to that, it eventually become a lake. Eventually that lake will become an ocean. And this is what we mean by scaling wide. So maybe 10 years ago, you had a front end, and it would fan out to a bunch of machines behind that. But if you were operating that front end or API server, you had a direct connection to all the other services that were involved. So if there was a problem, you could just talk to those people. So another example to contrast with that, this is a village. This is an organization, a bunch of people, their work, their lives. And of course, if you add people, eventually you get something that looks like this. And this is what I mean by scaling deep. But scaling deep is different, right? The way that we think about navigating a village is totally different than we think about navigating a city. The kinds of structure, the tools there are just new things, right? If you want to find a piece of information, if you want to find a person in a village, you probably just ask around, right? In a city, there's all kinds of different hierarchy that you have to navigate to find someone. So this all seems maybe a little bit abstract, so I want to talk about software for a minute. At Lightstep, we see a lot of different ways that folks build systems. And so I looked at a few things, and I grabbed some data from one of our customers, and I plotted their architecture, right? So I looked at their different services, how they broke them up, and the dependencies between those services. So on this, the dots are, the circles are individual services, not instances, but just the abstract service. And then the lines are some RPC or other remote requests between those. And if I zoom out, and maybe zoom out a little bit more, maybe a little bit more. I don't know if you can still see any of the details on here, but this particular example is about 10 levels deep. And these are just the services involved. So this doesn't say anything about the internal structure of those services, whether there are libraries or frameworks there. And it doesn't say anything about the infrastructure that's underneath, whether that's the operating system, the cloud provider, anything that's underneath that's making this all work. And I guess the thing that I think everyone to take from this is really the source of pain that a lot of developers are experiencing today. As an engineer, as a developer that owns one of these services, I'm responsible for the performance of my service, but I'm indirectly responsible for all of the services that I depend on as well, because those are all going to play a role in the performance that my service provides. But I don't have control over those things, right? And I might not even know that they're there. So it's pretty likely that the performance of my service will depend on something that's maybe 3 or 4 levels down that I didn't even know was part of my system. Now, I don't want to say that your system has to be 10 levels deep in order to have this kind of property because the complexity really grows geometrically with the depth because of the fan out, because of the interactions between those dependencies. And so really, I think even if you have a system that's only a depth of 3 or 4, that's already a lot more complex effectively than one that's only 2. And this is, again, to contrast, before you had a direct connection, maybe with each of the important systems, now there may be many levels of indirection there. So with that, I kind of wanted to bring Thomas into the conversation. And so welcome, thanks for being here. So first, maybe we just talk a bit about systems that you've worked on where there was this kind of depth.
Yeah, so at Stitchfix, I'm kind of responsible for taking all of our machine learning models and getting them integrated into the business. We kind of have our standard technology organization of engineers who are building, the website and the mobile app and internal tools, and then we try to provide this infrastructure that allows them to either augment their tools or change the business process to make it very favorable for algorithms to optimize. And so that's a lot of the infrastructure that I work on, but I'm not a data scientist, so it was very, actually when we started out, we had kind of that monolith system that I kind of controlled and maintained and had a bunch of different PhD statisticians contributing to the code base and reaching into private libraries and whatnot, and so that was kind of the impetus to start breaking it apart. And then there was a whole 3 or 4 years of learning of how to do that effectively to keep the data scientists iterating quickly, but keep uptime and keep me sleeping at night.
So data science and microservices, it's all the buzzwords?
All the buzzwords, yeah.
Was that, so there wasn't, that was an intentional change that?
Yeah, I think it started off a little bit by accident. So the data team at Stitchfix was kind of pulled over from Netflix in the very early days, and we're definitely one of the early champions of microservices. So it was like, oh, we're going to do it in this new context. And I think it kind of started happening by accident. And then we ran into the problems really quickly, and so we had to be very intentional about how we wanted to move forward in this world. And so that was, when I joined, we were doing microservices, but not particularly well. And it was really hard to debug what was going on when the inevitable failures happened.
Yeah, so I was going to ask, what were the signs that something was going wrong?
I just mean the debugging cycle would always be, you'd get paged for, your proxy service, and then you pull up the logs and realize, okay, well, the stack trace isn't there. The stack trace is just saying there was a 500, so you go to that service, pull up the logs for that, and okay, well, there's 500, and you realize that depending on your alarm levels and the different, you won't get paged at the error site first, necessarily. You'll either get paged for all of them, or you won't get paged for the underlying service because it gets way more traffic and it represents less of the total volume. So if you're getting alarmed on a P99, you might not actually get the error at the call site. And so that was kind of the first signal to us that was like, okay, every single page is taken like half an hour just to figure out where the error is. Okay. So that was the first sign.
Just thinking about other sources of complexity or that kind of depth, are there other things in terms of the platform, the architecture, the infrastructure that you have that led to sort of more uncertainty in that kind of debugging?
Yeah, so the one thing that's interesting about the data science context is that you can check for your standard measures of uptime of latency, if it's an HTTP request, returning 200s, no failures, these sorts of things. But that only covers a small class of errors in the data science landscape where you have a model that's producing like a ranking algorithm that's producing kind of search results. And something may have degraded in the system where the search results they're returning, and they're returning quick, but they're not good. And so this is a thing that we're still navigating internally. It's not obvious. It's certainly not something that you can get off the shelf, an off-the-shelf solution to figure it out. So that's led to a lot of complexity. That's just, it's not just your standard like logging metrics and tracing that is enough to debug these systems. There's a lot else going on.
How does that play out between the teams? Is there friction there, or is that something you've had to work through?
Yeah, there's definitely friction there. So one of the things that my team invested in was building kind of a semantically aware debugging tool that allowed you to debug the recommendations. So to give a little bit of context here, we have tool internally at Stitchfix that our stylists use to help navigate our inventory. We have way more inventory than a stylist could possibly navigate for a client, so we use recommendations to help them design the outfits. But that recommendation, it is just a single endpoint, but it gets decomposed into about 10 or 12 different models that are simultaneously optimizing for different objective functions. And so, you'll get a stylist that will pipe up and say, hey, recommendations are weird. Who do you call, right? I mean, they call me, but I don't know. I mean, it's 10 different models. I didn't write any of them. And so our first stab at it was writing this kind of debugging tool that allowed them to pull up and kind of get that waterfall debugging for how these models are composed, and kind of allow people to step through and figure out where it's getting weird, because they're all returning results, and independently they seem like they're working, but they interact in a weird way. And this is just stuff that you can't, I mean, in standard software engineering, you have methods to solve this, but they don't translate to kind of these non-deterministic models.
Yeah, interesting. So you talked a bunch about pages and understanding, so that kind of brings me to the second thing that I wanted to talk about, or second concept that I wanted to touch on, which is observability. So, the term comes from control theory, and sort of textbook-wise says something like being able to predict or understand the internal states of a system based upon some small number of outputs of that. But I wanted to ask you, I mean, you're talking about pages in 30 minutes, like what does observability for you mean in your work?
I really think about it as a way, and this is probably being influenced by the scientists, is that observability is, the lens through which you can poke and prod a system to understand it. As you mentioned earlier, there's so much complexity being added to software, and if you can't measure it, you have no hopes of understanding or running tests. So there's kind of two components to it, which is like not only seeing what's going on and being able to measure it and have these type of metrics, but be able to safely run experiments in a live system to see how it affects, so you can understand the system, which is, I think, a pretty big departure from like standard software engineering, where it's like pull down the universe, run a set of integration tests, isolate it down to the one line of code. It just doesn't work in the data science context.
Yeah, talk a little bit, if you can, about some of those kinds of experiments.
Yeah, so in our microservices kind of architecture, each microservice is a version of a model. And then we have kind of other microservices that help and compose those. And anytime a service calls another service, we actually have a routing layer in between, which can be augmented, or the routing logic can be influenced by some static set of targeting rules. Well, I guess they're not static, config-based targeting rules that you can edit in the live system, but as well as like A/B tests. So what we can do is, we're getting a complaint that the styling recommendations are wrong for some definition. We can come up with a hypothesis and say, hey, you know what, I think we use kind of a non-deterministic definition of what inventory is available in our warehouse, and we're trying to optimize for different things there. And so what we can do is in the live system just set up an A/B test down to a heuristic-based model or a simpler model and see if that goes and live affects what is happening with styling. And so this is the kind of the infrastructure that we've built in, and it's kind of gets that observability and control stuff, whereas any function in our infrastructure, we have it such that any function can be flipped to another version of it, or a heuristics-based approach instead of a machine learning-based approach, and then you watch the metrics and try to see what's going on.
I see. So not even necessarily trying to find the root cause, or maybe changing the system in order to discover how it's working, rather than trying to just understand it sort of in a static sense.
Right. I mean, some of the times the error is just, hey, there is a weird interaction between like this objective function and this one, and like what model is trained to learn them, and so that's stuff where, I don't have the skill set to debug those, but I need to provide the tools to allow the data scientists who are not particularly the strongest software engineers to be able to do that themselves. And that's a really interesting challenge that I don't see a lot of people talking about, and I just don't think a lot of people are having it. I think it's a little bit unique.
Yeah, I don't know, maybe there's not really even an answer to this question, but like how do the data scientists think about observability? Do they just think about you?
Yeah, pretty much. To be frank about it, they generally, pages get routed to my team, and then we're highly incentivized to make sure that we're building the tooling that allows it to either automatically be routed to the model, the team who's responsible for the model, because they go super deep into those models. They're creating many versions. They're not thinking about the whole system. They're just thinking about their one objective function, because that's what they're studying. And so when they think about it, they get paged, and business partners are kind of reaching out, and we're really thinking about how can we route errors to the appropriate team automatically,
Okay.
and help provide people the tools to determine where to route it. Yeah.
Yeah, you talked about routing and handling pages. Are there other times when you can think of when you didn't have the observability that you wanted, and sort of how did that manifest in your team?
Yeah, so I mean, the reason why we started focusing on it is because we, launched a new feature internally, or a new set of models internally, and there was all these kind of unintended consequences of it, and it was literally, my phone was blowing up, for every hour of every day for like 2 months, and I was like, just went to my coworker, I was like, all right, can you keep the ship afloat? I'm gonna go build something to solve this so neither of us are called.
Yeah, okay.
Yeah.
So maybe then thinking a little bit from a use case point of view, if you were going to define observability just from those kinds of capabilities, what would kind of be the top of your list?
So the standard kind of software engineering stuff of like, you need to be able to see what's deployed, where it's deployed, links to the code, who's talking to who. If there is anything kind of dynamic about the system, that should be always shown in the context in which it's useful. Mm-hmm. So there's plenty of logging and this, but it's not just like producing data, because you can do that till the cows come home, but unless you're showing it in the context in which it's useful, it's wasted effort.
And useful for you, what is that? About quality or?
Well, so I mean, there's some little things about like just usability of your monitoring systems. If you're looking at a trace, being able to link out to the code of the function that produced the trace. So you get some level of granularity in your open tracing, but under the hood there's another stack trace in whatever environment you're running, and so being able to have that kind of cross-linking and aggregated metrics at those levels as well.
Got it. So, you touched on this a little bit in terms of thinking about experiments. So if we kind of go back to control theory, the dual of observability is controllability. So that's maybe if your math and you know what a dual is, then it's the ability to control that internal state based upon some small number of inputs. And I think you need observability and controllability, at least for any kind of interesting system. It doesn't really do you any good to understand what's happening in the system if you can't control it, and if you have the controls and you can't understand what your target is, then that doesn't help either. I wanted to ask, do you feel like systems in general, sort of that you've seen over the years, are we getting more controllable systems? Are they getting less controllable?
I think the standard direction, if you're not mindful of it, they get less controllable.
Okay.
But that's not to say, doing a broad survey of what's out there to say that we don't have controllable systems, but I think unless you're thinking about it, it doesn't happen. Yeah,
and so how do you remind yourself to think about it? How do you get others to think about it?
So I put people on call.
Okay.
I kind of have a belief that we generally think we're better at abstract thought than we actually are. And so we can go through these theoretical exercises on the whiteboard, but it's not until someone is on call that they actually appreciate the concerns. They can kind of academically know something, but haven't internalized it until they've actually felt the pain of not thinking about controllability of their system and observability. And so the biggest way that I get my systems I've gone through the pain of on-call enough to know the value of it, but for new members of my team, that's a big part of it, is like doing the training, giving them the tools to run the experiments, and try to do it in a safe environment where they can debug the live complexity. And this is where the mentality of the scientist that I think really bleeds in, where it's, you don't know the system, You have to come up with a theory about it and poke and prod it to understand if your mental model of what is actually happening in the world is correct.
Yeah, you mentioned making it safe. How do you think about making that experience safe?
So there's the classical way is doing this with a staging environment, but as you know, these systems, creating a full replica of the universe is not always possible. So I mean, we've done some little techniques where in the data science use case, a lot of the recommendations, there's not a lot of writes, it's a lot of reads. You produce recommendation. It's the recommendation is a little bit ephemeral, and then you produce some logs which go back in your training, but that write cycle is potentially days or weeks. And so we really leverage that to do something. We do like traffic shadowing internally. So we'll have our models, we'll have 2 versions before we go and push it into production. You can go and deploy it and say, hey, for every 10 requests that model version 12 gets, send one to version 13, produce some logs, and then we can kind of compare the results and kind of try to run those. It's a little difficult to do, but try to run those counterfactuals of like what would have happened if this actually was running in production with real live traffic.
Yeah. You mentioned on-call. Are there other, maybe thinking a little bit more broadly than the software itself, are there other ways that systems are getting more complex, either in the people, the processes, I don't know, vendors, things like that?
So I think there's some interesting interplay with how software engineers are kind of classically trained around agile or just how you write software. I mean, if you take a standard engineer and throw them, or a classically trained engineer and throw them into a microservices environment, their natural tendency is going to be like, okay, I want to go and understand the state of the world, so I'm going to create a big Docker Compose file and try to like pull down the universe so I can like debug everything, but then you're not really having microservices, you're just having a monolith with network boundaries. Yeah. And so like that, I think that is the natural tendency, and so it kind of requires a different way of thinking about software engineering, and that's what I think is a big kind of people and process struggles, that a lot of process came out of the known truths of how to write software in this kind of monolith world. And I think that really needs to be reevaluated. I don't have specifics on that, but
how should we be training people?
Yeah, no, I mean, I'm still trying to figure it out.
Cool. Maybe kind of trying to put the two together a little bit. Are there ways that we could be better observing things to support better control?
I think if you are the intermediary between 2 systems, to design the system such that it's like very obvious what it's doing, and anything that is dynamic is logged and shown and can be overridden. And so, that infrastructure that I was talking about, where any model can kind of be switched from version A to version B just through a UI, you can just carve off 10% of the traffic, send it in one direction or the other. It's also in the power of the caller of this model to override the logic of where it's going, and that's well known and well logged. And so you can go and you could imagine kind of conceptually you're having a website, there's different parts on the website that are dynamic. If you have that kind of controllability through the system and it's plumbed from service to service automatically, you could build debugging tools right in your application that says like, hey, if I'm an admin user, I can push question mark and I can pull up every version of every model that was used to render this page on the website. And then I could reload the page and override to say, instead of using version 12, use version 13. I don't need to go allocate new experiments. I can just do that kind of live. And that's that level of controllability that like needs to be built in the system and needs to be end to end. Otherwise, you're never going to be able to have that ability.
Yeah, that's great. I was thinking if you were going to go back and build this all again and think about the bright future that we could be in, like how would you have done it differently?
I feel like if I knew that, I would be doing it right now, because there's plenty of new things. A lot of the lessons that I've learned were born out of struggle of doing it wrong a bunch of times. So, I mean, I would just say, hey, take the infrastructure that I have in production right now and just build that from the start. Yeah, I don't know if I have a good answer for that.
Yeah, maybe another way of thinking about it is like what's the kind of low-hanging fruit that you still see? Like where are the opportunities that you're excited about?
Yeah, I mean, in a less Stitchfix related, but more kind of broader industry of, there is kind of this conversation about observability that goes around metrics, logs, and tracing, and there's kind of like in my eyes, that a lot of this can be derived from a trace. Metrics, it's just a trace can be the data structure by which you build your logging systems and your metric systems, and obviously your distributed tracing systems. And I think that there's a lot of work the kind of industry could do around that, and so you don't have to have in your code, you see some code bases where you end up having like a log line and then like a statsd metric emit and then like, add some tag to a span. And if that could just get rallied around, you could get a lot of unification there, and I think you could get a lot of nice interplay where you can have specialized systems for processing those data structures and indexing them in a way that's useful without burdening the developer with using the API of each custom, whether it's logs or metrics or tracing. So that's a big thing that I think hasn't been done, and should be done.
Yeah, I mean, I would be remiss if I didn't mention OpenTelemetry at this
Yes.
point, which is a project that we at Lightstep have partnered with others with to basically do that kind of unification in an open way, so that folks like you don't have to choose a vendor ahead of time, and don't have to choose 3. You can just pick one standard.
Yeah, I'm super excited for it.
Maybe more on the people side, you talked some about on-call and about training. Like, are there more things that you think that the software engineers could learn from the scientists, or vice versa?
Yeah, well, I think it really does. I mean, it's a nice thing being at Stitchfix, because on the data team, the engineers are, it's like 4 data scientists to every engineer. So it's pretty hard not to pick up a few things just through, lunchroom conversations. And I think that kind of scientist mindset of like, be okay with the fact that you don't understand what's going on, like embrace the chaos a little bit and use the scientific method to, charge forward despite of it, because like, this is happening in the world, right? And it's going to happen. There's a lot of good that actually comes from microservices of autonomy and iteration, and you can get people that can go really deep on a system way quicker, or many iterations, sorry, on part of a system way quicker through this kind of microservice world. But I think the natural tendency of a software engineer is to shy away from that. It's like, hey, I don't have linters, integration tests, all of this stuff, which I think it's a new world. You just have to embrace that and come up with tools that allow you to reach your SLAs in spite of the downsides of the microservice architecture.
Yeah, okay. Maybe thinking up the organization a little bit. When you say SLA, I always think a little bit about accountability. What do you think about from not just maybe your teams or your peers, but how do you talk about this with leadership and sort of motivate some of the changes that you want to make?
Yeah, so I'm pretty fortunate that I report up to Jeff Magnuson, who came over from Netflix, who kind of championed it and taught me all of this stuff. So luckily, it's a lot of him petitioning for this kind of stuff, and I just, we're pretty well aligned on that. I think it really just, you have to, there's going to be like growing pains as you're switching from kind of one paradigm to another, and you just have to be really accountable and there in front of the computer and debugging issues collectively, so people can kind of learn and observe, because it goes back to that, like, knowing something academically versus internalizing it. Like, we could write a blog post about it, get shared around on Hacker News, it'd be great, and everyone will parrot it, but it probably won't change behavior. And the way that happens is that you need to be in the room with these people and kind of showing them, not telling them. And I think that's really kind of the right approach is, show them the positive outcomes of such an infrastructure in a isolated or like a well-encapsulated area of the business that where you have the freedom to do so.
Yeah.
Right?
Yeah.
Instead of saying, a whole wide sweeping change of
Yeah.
the entire business and just make it a 2-year strategic initiative.
Yeah. That always goes well.
Yeah.
So maybe just to kind of wrap up a little bit, in terms of closing thoughts, like what do you think we'll look back on, I don't know, 5 years from now in terms of observability or control, and what do you think will be, I don't know, what will we look back on and be excited about?
Sorry, excited about from 5 years ago?
I guess we could be sad about it.
Or,
Sorry,
yeah.
looking back from now to now from 5 years in the future.
Yeah, well, so I think we're going to kind of laugh at how we do microservices today. We'll learn a lot in the best practices of how to do it. I think looking forward, we can be really excited about I guess what I'm kind of thinking is like a lot of the fears that we have around the complexity, I think will be like well solved, and I don't think it's just a tooling thing. I really think it's a way of thinking of how you develop these systems, and I think we'll go and we'll look back and say, oh, those were all misplaced fears. It's fine. The kids will be all right in this sort of situation.
Cool. All right,
Yeah.
That's great. So yeah, with that, I wanted to thank Thomas for joining me up here. It was great to talk with you things, and thank everyone else for your attention.
Thanks.